Thank you so much. Hello, everyone. Welcome to Data Weekender, and I'm so glad and honored to be here. Um, I hope I'll be completing this in 10 minutes, but let's get started. So, I'm going to talk about the SQL in statistics internals in 10 minutes. I hope I'll cover at least some of them. Um, so, before showing you the statistics and how they look like, I would like to show you how a query executes on the SQL server. So whenever a query runs on the SQL server, it will check if it is running for the first time and it will go through the transformation and build some execution plans and see which one to choose. So based upon the cardinality estimates, meaning the SQL Server statistics, it will check on each of them while going through this transformation phase, and it will build the cost for each of the plan. And based upon the cardinality estimates, again, the SQL Server statistics on the tables, right? So the least cost ones, meaning like any execution plan which is costing less, that will be the winner and it will be saved inside the plan cache. So that is the first part, right? But the that plan will goes to the execution phase, right? But before the plan goes to the execution phase, based upon those cardinality estimates, based upon your SQL Server table statistics, their memory grants are allocated on that query, on that execution plan. So the memory grants are allocated even before the query goes to the execution phase, right? And then it will go through the execution phase by using those memory grants and all the resources, CPU, memory, all of that resources. And that is the actual process of the query execution. But what if your statistics, SQL table statistics are stale and they are out of date? Due to that, the cost will be affected because while going through the transformation and building the execution plan, it will check for the SQL table statistics because that's how it will make the estimate of how many rows it might get back to us. So that cost will be affected and a wrong plan might be saved inside the plan cache. And due to that, the wrong memory grants are allocated, right? Even before the query goes to the execution phase, the memory grants are allocated. So if the stale statistics shows less number of records that are going to show up instead of the actual number of records, then that will definitely impact the how much memory grant has been allocated. Only few memory grants are allocated, and that will impact the query execution. So all of this is happening just because of the stale statistics, right? So that is the reason why I put here it is so important to know, like, to make sure that we are updating the statistics and make sure that they are up to date all the time. But what are these statistics, right? The statistics are the blob structures inside the system tables, and all they do is they show you the distribution of the data in your table columns. It can be one column, it can be multiple columns, and it can also show you the flow of the data within the indexed views as well. So if these statistics are not up to date, then the execution plan will be affected, which will create the non-optimal plan that I have shown you in the previous slide. But let's see how these statistics looks like, right? We can use the DBCC show statistics, which will provide three information: header, density vector, and histogram. Now we are going to see all of this in our demo, but um, so what is a density vector? Density vector is nothing but it will show you how unique your values are. So how does that be calculated is it divides one divided by the total number of distinct values, or the combination of the columns, which will show you how unique your column is. So you can also get the same information by using these two sysdmdb stats properties and sysdmdb stats histogram as well. But let's explore by using the dbcc show statistics. So here I am using a reputation column on my users table. So dbcc show statistics give the table name and the column name that you are looking for. So this is the non-clustered index. When I created, it automatically created the um, statistics on the top of it. So whenever you create the index, an associated statistic will also be created on that column. So let me go ahead and show you how this will actually look like. So as I mentioned, when you use the DBCC show statistics, it will show you the header, density vector information, and the histogram itself. So the header information will show you the column name, the statistic name again, and how many rows are there inside that column, and how many are sampled. Like whenever you are updating the statistics, are you sampling like percentage or how much? Here I can see the sample rate is similar to the number of rows, which is 100%, the similar number of rows, right? So I'm updating it 100%. And the steps, what are these steps, right? Anytime you have a statistic, like I mentioned, it is saved inside the system table showing you the distribution of the data with it about that column, right? So it can be up till 200 rows, and sometimes it can be 201 rows. That one row additional is when you have nulls in that column. If you have nulls in that column, then it will show you 201 rows, but it can be less than 200 rows, right? So here, the statistics on the reputation column is having just 194 rows. That's what it is. And density is 0.04. So what is this density, right? Density vector is something shown on here. So on the reputation column, it can be mixture of columns, right? On reputation column, this is 1 divided by the number of the distinct values that are there in this column. That's how the density is calculated, and the lowest the number, the highest unique values we have. So um, that is like if you have any unfiltered rows, it will also show. We do not have any filters on it, so that is the reason we are seeing the same number of values. Now let's go to the histogram in interesting part. So here we have couple of rows, a couple of columns here. So range high key actually represents the value of the column itself. So here we are seeing the reputation column, right? For the reputation value number one, we have equal number of rows. These many rows, we have equal number of rows for the reputation value one. In the similar way, if you see, not all the values are represented here because we can have up till only 200 rows. So it is just showing you the distribution of the data by taking sampling of the values, the reputation IDs here. Though these are the IDs that are represented here, but the equal number of rows represents like for reputation ID 3, we have these many rows. And what are the range rows here, right? The range rows represents how many value of how many rows does we have in between the values of reputation ID 1 and reputation ID 3. So those values are the range average range rows, right? So there is something known as the distinct range rows as well. So that will be like it will divide these two rows. So um, my head, I'm so sorry, my head is stuck right now. So so the the range it will take the values of 1 and 3, and it will show you the average number of the range rows between coming in between 1 and 3, that is 2. So those are the average range rows. So let me go ahead and show you how it will actually show. So this is a very simple store procedure that I have created. All it is doing is it is selecting from the users table and searching on the reputation column, right? So I have already created this, but let me go ahead and create it again. And then I'm doing some filtering, but I'm just bringing up that histogram on the reputation column again. So let me go ahead and run this. So I am ordering on the equal rows. So in the descending order, so you will see all the equal number of rows. If you scroll down your this mouse, you'll see as I'm ordering on the equal rows, you'll see all the way from the highest values to the lowest values. So based on that, I would like to um, run these three executions on the store procedure with three different values, right? These are very sensitive, meaning like if you see the value of the reputation 5714 here, the equal we need to see the range high key because I took the specific value from here, which is 5714. Now, if you see 5714, it should be somewhere in here. 5714. If you see, for this value of reputation ID 5714, we have equal number of rows 8. So if I execute this, you will see only 8 rows coming up. If you see the execution plan and results, you will see I executed it 3 times, right? So I have seen only 8 rows. And if you see the execution plan, now the estimated number of rows are 8, but the actual number of rows are also 8. Now, why is it that so equal? Because my statistics are up to date 100%. And also I'm taking the equal number of rows, like the range high key value. If you see here, when I execute this, I took the exact value of the range high key. So that's the reason like why I'm seeing with the 5714 value, 5714, we see the number 8. In the similar way, I can also get with a different reputation value. If I see the reputation value 1, if I execute that, I can see this will generate actually too many rows. So with the reputation ID 1, how many values we have? It's still executing. Oh, I'm already 3 minutes late. Okay. Um, so yeah, it's like 1 million rows. But then in the if you see the value here in the execution plan, if you see the values are approximately like 100% because we are taking it directly from the range high key value, right? So that is how I wanted to show you just with the equality operator here. I did not show you the ranges here, right? I just focused on the equality operator here, which we can get it directly from the range high key. So within 10 minutes, I just covered that part, but thank you so much for giving me this opportunity. And sorry, I crossed the board 2 minutes. Thank you again.
Alrighty. So, I'm the crazy person who decided I could talk about establishing coding standards in an organization in 10 minutes. Is this possible? Theoretically, yes. We'll find out now. So, in case you're not familiar with me, my name is Jared Kuehn. Quick introduction. I'm a senior data engineer. I've been consulting in the data industry for about 10 years. But I'm two facets. One, I'm the technology nerd. The other part is I'm a storyteller. And the second part is especially important for me because if you go back to the dawn of time, the way we shared things to begin with wasn't from a bunch of series of Excel documents being reports. We shared information through storytelling. So that's what I'd like to do to tell you about today. Agenda-wise, I have nothing because we only have 10 minutes. Hopefully you can figure out the agenda from here. We'll launch right into it. Today's story starts here. Nope, it does not start with that AI picture. It starts, no, it does not start there. There we go. Okay, that's what I actually look like without glasses. It's got that Clark Kent thing going here. There's our actual presentation. Okay, so we're going to start a story here. You've been in this situation before. You, on a Friday afternoon, you've left yourself some menial tasks, nothing really complicated to do on your Friday, so you can coast into the weekend, relax, get ready for that Monday, and then you get that email. You get that email from somebody who says, oh gosh, I need these numbers prepared for Monday. I'm having issues with this query. I have no idea what's going on. Please, can you help me? And being a good coworker, you're like, okay, sure, I'll help them out. I've got some time. Okay, this shouldn't be too bad. They just gave me an email with 3 queries. I can do this, no problem. And that's when the voice gets really low because the narrator comes over and he says, but this was when he was doomed to have a bad weekend because he opened up the first query and it looks like this. What is this? There's parentheses all over the place, so maybe there's CTEs, maybe there's nested stuff. I don't know. The formatting's all over the place. Okay, that's just first query. The other two might be better right, but they weren't right because the dark voice said, nope, things are going to get worse from here because we open the next one and it goes, ah! CTE strings, multiple CTEs, and none of them are formatted the same way. Oh, that's even worse. Okay, well, third time's a charm. Third time was not a charm because he opened up the third one and it got even worse. Oh, okay. Maybe this one's exaggerated. Nobody takes their queries and they format them in the letters D and B, but you get my point. If you've worked with SQL code long enough, you've probably run into situations like this, being on a time crunch and needing to view code and understand code that is not easy to read. And that's my question for you to consider for these next 8, 9 minutes or so. How long does it take to read this? Not just to read it as in like being able to read the code, but to actually understand what the code itself is doing. If we look at it from that light, there's an interesting observation you can make. Is that formatting? Some people say it's not a big deal, right? It's not a big deal. Well, take a look at this study from 2023 from the International Data Corporation about the high cost of not finding information. And this isn't a Monty Python skit. This is an actual study. And I won't go through the entire study, but there's one key metric I want to highlight. The knowledge worker spends about 2.5 hours per day, or roughly 30% of their workday, searching for information. That's not actually gleaning any insight from it. That's just finding the information. And when we think about that, searching for information, that includes code. That includes our ability to not only find code, but to understand it. So when we look at it that light, the whole lens of formatting makes a big deal because it leads to some very alarming situations. Innate tech debt because people run out of time to effectively check their code and think about it in terms of best practices. Lack of collaboration. If your code's not pretty, I don't really want to collaborate on it. Time intensive bug fixes. If it takes me 4 hours to read this query, that's 4 hours I lose trying to figure out what it could be just a 15-second problem. The knowledge base could walk out the door. Has anybody been in that situation where you've been in an organization, somebody walks out, and now you're managing their code base, and not only is it undocumented, it also looks unpleasant. Nobody wants to be there. And what this could lead to in the worst case is a lack of trust in output from our business stakeholders, especially when we talk T-SQL, things that strongly impact ETL processes in some cases, or even reports. I mean, let's be honest. Wouldn't you be concerned as a business user if your entire code base looked like this? I'd be screaming if I were in that situation. So we need a solution. Hopefully that showcases that we need a coding standard. Now, obviously, with the couple minutes that I have here, we can't talk about all the ins and outs of a coding standard. Plus, there's a lot of resources online. If you search for, I'm trying to adopt a standard, where do I start? A number of places to go there to actually design the standard. But what I'd like to talk about instead is what are the other things you should be thinking about around designing the standard? I mean, we could talk about the standard itself in terms of, you're wanting to shoot for something that's a consistent style so that it's easy to read for any audience. You also want to think about things that are functionally beneficial. Good coding standards aren't just about making your code pretty, it actually makes it easy to edit things. If you're working with an IDE like SSMS, you like commenting and uncommenting lines with Control KC, Control KU, you want to make sure that your coding standard supports those situations so that your developers are better enabled to do so. And here's a big kicker, especially if you're not doing a coding standard in your org today. Don't give people a book. Give them 6 properties or less. Why? Most brains, once you get to 7 objects or higher, start forgetting things. And as we've learned from our technology, things that are in memory process faster, right? So we want to keep our coding standard in memory, not in storage. Most important thing when thinking about the coding standard, and this is where we need to talk about the more important things here, is a good coding standard needs to be agreed upon by anyone writing code, which means for something like SQL, you're talking not just your ETL or your data engineers, you're not just talking your data analysts or your report developers. Citizen developers that are writing SQL code should agree to this as well, because who's going to be the one emailing you on a Friday afternoon asking for support? Very often, it might be your citizen developers. You want to get them on board so that when time crunch happens, you're best ready to support them. Let's talk adoption quickly. So what does it mean to actually adopt it? Where you need to start adopting a coding standard isn't even by adopting the standard itself. You want to start with your sales pitch. Think of it this way. Oftentimes, when we think of priorities, we think of three things: budget, time, quality of product. Something like a coding standard is not budget or time, it's quality of product that can influence time. Sometimes quality of product is one of the most difficult things to advocate for. So you need to make sure you've got a strong sales pitch to get people on board with adopting a coding standard. And my only advice there is don't be like my buddy Sven. Sven is a really good guy. He's a very competent coding developer. But if he were to go in and to try and sell you on a coding standard, he more or less goes in and says, adopt my coding standard or otherwise I will leave this organization because I can't deal with ugly code. Does anybody actually want to listen to something like that? No. And I think a lot of times when people start, that's where they start, is saying this is something that has to be adopted. Yes, it's something that can provide benefit, but sometimes you go in with a strong hand, people don't listen. Think of it as a sales pitch. What benefit do they get? For example, I can get this code base to be more sustainable long term and encourage better collaboration with my peers because, at the very least, we're all agreeing on how our code should be structured. It's going to enhance all of those things. That'll get you much farther. Once you finally get people on board saying we go and do this, you define that standard and you enforce that standard with two things. First of all, get those code reviews in place in case you're not doing them today. Code reviews are a great place to not only say, yes, this code is functional and it's ready to go to production, but it gives us that extra time to say, is it adhering to the coding standard? And doing that in a group setting where you can also immediately see, based on your coding standard, do other people easily understand the code that you wrote? Great way to give you a litmus test on whether your coding standard is working well or not. Second thing you should do is what I call the keeper of the standard, which I mostly call it that way because I'm a D&D nerd and I like nerdy stuff like that. And it sounds really epic. But a keeper of the standard is who is going to make your coding standard a priority in your organization? Who's going to be the one that helps lead initiatives to define it? Who's going to be the one to sit in code reviews and make sure people are talking about your standard and encouraging people to make use of it and being an advocate for that? Something like this needs to be prioritized because, again, quality of product often gets sidelined compared to budget and time. You need somebody to make sure it stays up front, first and foremost. What does a coding standard look like in my mind? Here's at least an example of how I would define one and also tell you why I would define it this way. The items itself, again, left to interpretation, but the one I'll focus on today involves a couple basic things. SQL keywords in all caps. A lot of people like that. Helps at least give you structure even with nothing else in place. I encourage some things in terms of character returns, getting things so that your code is not wide, your code is tall. Easier to read because people like scrolling up and down. They don't like scrolling left and right. Matching that column name formatting with table column names. Quick way to get to lineage and alias your tables and use those in your column references, even if you're doing a single table query. You save yourself a lot of time as soon as you add in that second table. Couple basic things here, right? Again, 6 properties. This is not rocket science, but something like this takes a query like this, and I have honestly truncated this because otherwise I'd be scrolling my slide way off to the right, and nobody wants to do that, and turns it into this. I think we can generally agree that just a couple of properties turns that into that. We can agree that looks better, and that's much easier to understand, and that's even without any sort of comments within your structure. Part of the reason I structure my coding standards that way too gets to my last point. What about AI? And this isn't just a kicker to say I'm doing a buzzword and therefore I'm an AI specialist. I'm genuinely asking you the question, what about AI? Can AI help you with coding standards? Let me show you. So I'm going to go into my dear friend GitHub Copilot, and I'm going to paste in a particular prompt, which I prepared earlier, as any good cooking show does. The prompt is very simple. All it says is, I have some code. Oh, and it left out the G. That's not good. All it's essentially saying is 3 things. 1, my code does not follow a standard. I want it to follow a standard. Please reformat my code so it's following the standard. Second thing I can give it is my standard, which in this case is those 6 bulleted items, and I'm actually giving it a 7th one because of the query itself. This is our first query we had at the start of our talk today. And then I'm giving it the query itself that I want to format. If I run this, let's see what it does. Reformat here to current standards. So initially where tabs were all over the place, parentheses were all over the place, now at least with the coding standard, things are more consistently formatted, and I can quickly see what is this person doing in the base select statement. They've got like, this is a single column definition that is actually like 3 or 4 nested queries. Now, obviously, this is an exaggerated use case for demonstration purposes, but remember that initial statistic, 2.5 hours lost finding information. With that initial formatting, it would have probably taken me a good hour plus just to get this query formatted before I could start diagnosing this. This saved me an hour of that time in a critical situation. That's the sort of thing that can make a strong impact. And what made that change? A coding standard, and in this case, using artificial intelligence to help take existing code and get it to adopt our coding standard, in case we're adopting one brand new, or in some cases, we've got a coding standard identified, and we're just looking to understand code that isn't easily following the standard. AI, can it help with coding standards? Yes, yes, very yes, and I strongly encourage people to consider incorporating AI for this particular use case. All right, let's wrap it up. So, getting to the point here, what do you need to take away from this? Well, first of all, adopt coding standards when possible, especially with what I just showed with AI. There are fewer reasons nowadays because, again, what usually stands in the way of us enforcing a coding standard? Time. What is AI going to help us do in this case? Save time. So let's take care of those of that potential, and let's put it in for this use case. If you're looking for issues or for ideas on how to define the coding standard itself, again, look online. There are plenty of solutions out there, even for T-SQL, to help you identify that. More importantly, convince your business to support it. Enforcing a coding standard against something like code reviews. If you're not doing that today, that means it's going to change your project timelines, because you're going to need to do your code reviews well before your code goes into production. And also, people are going to be spending more time doing this. So make sure you have time in your projects to do so. And no matter what, avoid cursors. Okay, maybe that's a little bit of a joke, because in some operational situations it's beneficial, but in a lot of analytical cases, don't put those cursors in. It's not performant a lot of times, and there are better ways to do it set-based. If you ask me, sorry, it's not in my coding standard, so I'm not going to really allow you to do this. And if you disagree with that, I respect that opinion, but if you have an issue with that, take it up with my keeper of the standard, and I'll tell you right now, he does not mess around. I don't think you want to argue with this guy. Brings us to the end of the talk. Thanks to Data Weekender for inviting me here. It was a pleasure to talk for this group. Hopefully it gives you some things to think about if you're not doing coding standards, or even if you are. Maybe consider using some of these things here. If you'd like to connect with me, here's a bit of information on my socials, and that QR code goes to my YouTube channel. Check that out. I just released a music video not too long ago, and my new comedy sketch, Reports as a Service, which kind of gets into this topic as well.
All right, let's get underway. Welcome to Unlocking the Power of Analogies to Simplify Complex Topics. My name is Andy Yoon. I'm a SQL Server guy. That's really all we need to cover today. However, Deborah Malkin is my lovely spouse. She will actually be speaking a little bit later today, so stick around for that. And then this is our dog, Sebastian, who may or may not be making multiple appearances today. The thing about Sebastian is that he is a very curious dog and likes to ask lots of questions, such as this one, which is kind of surprising to come from Sebastian, but that's fine. I'm a SQL Server guy, and the Query Optimizer is one of my specializations. So you know what? I'm going to, give Sebastian a really detailed answer, because I want to be very helpful. I'm going to say, hey, man, this is how all of this kind of stuff works. But here's the thing. Sebastian may be very inquisitive, but sometimes he's not a hardcore SQL Server guy. So a lot of my technical, correct, detailed answers wind up going over his head, and he's really, really confused. And frankly, there are many times when we are asked complex questions by folks who are not necessarily subject matter experts in that particular area. Oftentimes, we have to explain very complex things to folks like managers, other folks who are very smart but may have other specializations, right? So my favorite tool to help break down something that pertains to us to help them understand more quickly is the analogy. So real fast, if you've never heard of an analogy before or not familiar with this concept, it's fundamentally just a comparison between two different things. And oftentimes the structure will follow an A is equal to B, B is equal to C, or X is like Y in this type of situation, or X is like Y because of blah, blah, blah. Let me give you a quick example. What is a firewall? Some of us are networking people, some of us are not networking people. But a very simplistic explanation, if I were to try and explain this to Sebastian, I might talk to Sebastian and explain how it's kind of like a security guard. And Sebastian's going to think to himself, oh yeah, I'm a watchdog. I like to protect the house and I bark at all the people who walk on by the house. So I understand that. I'm kind of like that firewall, but I'm in a dog form. Cool. That makes sense to me. I made that concept of a firewall simplified and relatable for Sebastian. So to that end, I want to help arm you with two key techniques on how to utilize analogies more effectively so that you can communicate more effectively with your peers who are not necessarily subject matter experts in the same technical domain as we are. So two principles we're going to talk about real fast right now. And the first one I already kind of teased at, which is all about simplifying and generalizing. This actually comes before the formulation of the analogy, but rather taking a pause when you answer a question to think about, how can I simplify this answer? Because here's the thing. We are all very, very smart people. We are all experts in our domain. And oftentimes being smart is actually detrimental because we are oftentimes too eager to answer in too much detail immediately. We need to pause, take a step back, consider our audience, and be like, okay, I need to answer this at a higher level. One of the acronyms that I really love that's used heavily in social media, on Reddit, for example, is ELI5. Explain like I'm 5. I like having this mentality when I'm like, wait a minute, I need to pull myself back to say, wait a minute, I need to try and explain this very technical concept in a much more simplified fashion. Because if nothing else, I need to make sure that my audience understands the foundation first. I can pile on the details later, but if I don't get the foundation first, they're going to be lost. So then when it comes to crafting a successful analogy, I strongly encourage people to focus on a familiar setting. A setting is a larger kind of environment or perspective, and one that is going to be as universal as possible, something that people can all relate to. The setting also needs to be flexible. Within that setting, there needs to be multiple different possibilities, little scenarios, if you will, so that way you can tailor different situations, different questions to different situations in that overall setting. Here's two examples. Grocery shopping is a great setting that is familiar to almost all of us. Almost all of us have gone grocery shopping before, right? So I might, for example, talk about bandwidth and multipathing concepts as far it's kind of like a checkout lane in a very, very busy grocery store. If you only have one checkout lane, you're going to get bottlenecked. But with multipathing and storage interconnects, for example, if I happen to have 4, I can now more evenly distribute traffic across those 4 lanes, just like I would distribute the shoppers across those 4 checkout aisles. A very simplistic analogy that I came up with very quickly, but it quickly relays that concept. Traveling by car. We've all been stuck in traffic jams, for example. We've all seen automobile accidents, for example. Or things of that nature. Those are all different things that we can draw upon, scenarios that we can create and craft analogies around, hence flexibility over a larger, broader setting. So what's my silly analogy to try and explain this particular question? Well, my preferred setting involves food. I love food. I also love to cook. I'm not the best cook, but you know what? I try and do best for Deborah. So when she asks for something for dinner, has a special request, I do my best to cook it up. So her query is kind of like, hey, Andy, you know, I feel like spaghetti tonight. Would you mind doing that? Cool, I'm absolutely happy to do that. So I'm kind of like that query optimizer. But what Deborah doesn't dictate, she does not necessarily dictate my actual recipe. Am I going to go to this cookbook and follow this recipe? Am I going to go to this other cookbook? Am I going to meld the two of them together? I, as the query optimizer, am going to come up with that, quote, execution plan, aka the recipe that I'm actually going to do to create that final output, that, you know, that pasta dinner that Deborah has requested. So that's kind of my, it's me making different judgment calls. You know what? We happen to have the basil is really fresh today, so I think I'm going to use some of that. You know, we have dried pasta, but you know what? I feel like doing something a little bit special. Maybe I'll make some fresh pasta instead. I'm making these judgment calls, and in some regards, that's kind of what the query optimizer is doing as it's coming up with its game plan or its execution plan, right? So that's how I draw upon something that's very universal, something that people can relate to then try and better explain or you know, kind of deconstruct. That's the word I was looking for. Deconstruct this very complex subject matter to lay a foundation down. There are definitely technical nuances that I left out, like, oh, well, you can use query hints to influence the query optimizer. Well, yes, but we're not getting into those details later. The initial analogy is meant to set the foundation. We can worry about the details and the nuances next. So, if you want to start making better use of analogies, understand that analogies oftentimes involves improvising. We're asked a question, we got to think real fast on our feet to then come up with something. The funny thing about improvising, though, is that good and successful improvisation requires preparation. Improv comedians actually practice. They come up with a library of scenarios and materials to draw upon. So that way, when they are asked or given a funny situation on stage, they'll immediately pivot to something that they've already kind of prepared and will quickly adapt it on the fly. So you actually need to kind of think ahead and prepare. So to that end, I'm going to encourage you to practice. Think about the times whenever you have to answer a question for someone, whether it be something technical, maybe you're just talking to your friends and family about something and you're answering a question. And then ask yourself, how might I ELI 5, explain like I'm 5, and take that answer and, give it, reframe it at a higher level. And then think about, whatever familiar setting you want to choose. How might I answer that? And how might I craft an analogy to try and better answer that question utilizing an analogy using whatever setting you are most comfortable with? So I hope these two techniques will help you out on your journey to utilizing analogies more effectively. I want to say thank you for your time. And are there any questions?
Oh, all right. So that sounds great to me. All right. Well, thank you very much for having me today. I love lightning talks. I love going fast. I love covering topics that can be kind of succinctly dove into. This one's more technical. It should be some fun. I'm going to talk briefly about column store index compression. This is not a deep dive. I have those. I did one at Past Summit. I can go on for 4 hours. We don't have 4 hours. But this is the key to how all analytic data is stored. So this is about column store indexes, but this can apply to really any columnar analytic data. So let's dive right on in. This is who I am. I'm Ed Pollack. I'm a data platform MVP. I publish books and articles and speak at lots of events. I organize events. If you happen to be anywhere near New York City, May 10th, we have a SQL Saturday coming up there. Please check it out. If you're nowhere near New York City, that's cool too. But if you happen to be, great. This is going to be a very brief review of how column store indexes are stored. We're going to talk about compression in brief, just giving some examples. And if there's time, I will throw in demos, because why the heck not? Let's just throw as much in as we can. And then summarize by saying, why is this important? Why do we even care about this? Because there are reasons to care about how our data is stored, especially when your data is very, very big, like analytic data, which can get ginormous. So efficiencies there can mean terabytes, petabytes saved. And so we do truly care. And as we all know in the SQL world, storage saved is I/O saved, it's memory saved, it's CPU saved, it's lots of things saved, which is money, right? If you're in Azure, that's your bill every month going down. So we do care about those things a lot. At the end, we'll wrap up. I'll ask if we have questions, and we're done. So the key to column store is that it's the total opposite of row store. You have your classic B tree cluster indexes, non-cluster indexes, and everything is stored row by row. If you have 6 columns, you store a row, column 1 through 6, row 2, column 1 through 6, and so on. But in the column store world, it's completely flipped for compression reasons. We store data by column. So here's a fictitious table that has 6 columns, and we have a bunch of rows. So what SQL Server does to column store it is, first of all, each column is stored separately, completely separately in separate data structures on storage. Next, the rows are broken into chunks of 2 to the 20th rows. We're going to call it, for simplicity's sake, about 1 million. It's a little more than 1 million. You can math it out. So this fictitious table here shows we have 6 columns and 4 row groups. So we have about 4 million rows, and there's 6 columns. And so what that means is SQL Server is going to store each column separately for each row group. So row groups, columns, therefore 6 columns, 4 row groups, 24 separate, what we call segments. And the data gets compressed separately. So each segment is compressed differently. And that's the beauty to all this. The magic of all this is that we don't compress it all together using one algorithm, but each individual segment can be compressed differently using different compression algorithms. This is optimized for OLAP data, for analytic data, machine learning, AI, analytics, dashboarding, that kind of stuff. If you're doing transactional stuff, this might help you a little for like log data and such, but you don't use it quite as much in transactional world, though you can. There are use cases for it. The basics to column store compression are key here. Each column is separate, and that's a big deal because in analytic data, the data within any one column is going to be the same data type. That's a given, right? If a column is a tiny int, every value is going to be a tiny int, right? If it's a varchar 30, they're all varchar 30s, whatever. And so each column is compressed separately, meaning each compressed structure has the same data type, but more than that, values repeat, especially values close to each other in time. You know, say we loaded 1 million rows into a data warehouse today that have a status type, and there's 6 options. Well, we know they're going to repeat a lot, and repeated data compresses beautifully. And they're not being compressed alongside other columns, they're being compressed alongside the same values, the same data types. A lot of these types of data types compress beautifully. Dates, times, money, counts, things like that. Lookup and dimension keys, all those foreign key values. Those things all compress beautifully because they repeat, repeat, repeat. Repeated data is beautiful for compression. And if you're thinking about how does this look, you really can just take the row store structures you're used to and just flip them sideways, transpose them, turn your head sideways, 90 degrees like this. You'll look a little funny, maybe like this. And you'll have the right idea. So when we compress column store data, there's really 3 steps. Step 1 is encoding. Encoding is a process where you take data and you rearrange it to reduce the storage footprint, and it's lossless. That's key. There's no lossiness here. It's not an MP3. We're not shaving off some numbers off the edges. The end result can be giving you the values back that you would have gotten with the beginning start. There's no difference in terms of what data actually is. There are many methods used in SQL Server, such as dictionary encoding, value encoding, and bit packing. I'll talk about a couple of them. All the algorithms used here are very inexpensive. They're well established. They've been used in computing for eons. So they are well known. None of these are mysteries. They're very well documented. And a really great thing about column store that I specifically like that not all platforms give you is that everything about your column store indexes are documented in dynamic management views. I have a couple examples here of sys.column store segments. Has column store segments in it, one row per segment. Sys.column store dictionaries. A row per dictionary, you have dictionary decoding. So SQL Server tells you exactly what you have, and you can review these and join. I have some example queries here I'll send out later that you're free to steal. Please don't copy off the screen if I get there because it's a lot of stuff. But again, encoding, inexpensive, simple, reduces data footprint. Here's an example of dictionary encoding. Dictionary encoding basically says we're going to create a hash table of all of our values, and instead of repeating the values over and over and over and over throughout our segments, throughout all of our rows and everything, we're going to take and do pointers back to the lookup values. The nice thing about that is the lookup values can be small. It's just some numeric, right? Here's some example data. You are free to imagine that the actual data is 1,000,000 times the size of this. Imagine you're like, Little Debbie or something, and you have, billions and billions of cookies being sold every year or something like that. Or you're a bakery that sells thousands a day. Here's examples. These are all strings. Strings don't compress great. They compress okay, but there are repeated values here, and that's the key. The total byte size here, assuming varchar, not in varchar, is 203 bytes, 1 byte per character, and we have piles of characters here. But note some values repeat. People love those double chocolate brownies, but I guess the blueberry scone isn't so popular. So here's what we'll do. We'll create a lookup table. It turns out only 5 different values are actually represented in our data here. Only 5 baked goods have been purchased in this set of sample data. And so therefore, we only need 5 IDs to point back to our dictionary. So here's our dictionary on the right side here. We have 5 index IDs, 0 to 4. We have the string values and the bytes. So the size of our dictionary is 82 bytes. Great. That's wonderful. That's small. That's good. Then our next step is to take our actual values in the table and point them back to our dictionary. And the beauty of this now is that we're not storing strings anymore. Our dictionary encoded data is just these 3-bit numbers that point back to our dictionary values. They're just values 0 to 4. That's it. That's great. So now each value is 3 bits, and so we have 33 bits, which is not that much, like 4 bytes. So our total storage now for this data went from 203 bytes down to about 86 bytes. That's a huge savings. A great example of how dictionary encoding can save a lot of space. Another thing that SQL Server can do, and a lot of algorithms do out there, is bit packing, where it basically says, you know what, you fixed with values, like ints, small ints, whatever, that have leading zeros in the front, right? If I store the number 30 in an integer, that's just going to really take 5 bits to store. The rest is a bunch of zeros, 1, 1, 1, 1, 0. So bit packing just says I'm going to remove all of those leading zeros, store the values without them, and save space. It's a very simple algorithm, very easy to use, and you can shrink data a lot. This sample set of data right here goes from 288 bits down to 108 bits. And you can bit pack anything, including your dictionary lookup encoding. So you can encode encoded data further, which is pretty cool. You can apply multiple algorithms to the same data to shrink it, shrink it, shrink it, shrink it. So when people say column store shrinks the data by like 50%, 80%, 90%, they're not being sarcastic. They aren't making things up. Second step in column store compression is optimization. A really cool feature in column store world is that within a row group, order doesn't matter at all. The rows can be ordered however you want. It's not a clustered row store. Order doesn't matter. The optimization process reorders the rows within the row groups. This is expensive, though. This is an expensive process, so we don't do it all the time. We do it when we create row groups, and we compress them and create them. In SQL Server, vertipack optimization is used. In other algorithms, you'll see V-orders, Z-order optimization, stuff like that, liquid clustering. They're all trying to do the same sorts of magic to reorder rows and help you out. And the key here is that it's going to reorder values, chunking together similar values. That's what a sort does, right? Now, how does that help us? Well, here's what optimization does. I got a bunch of values on the left, and they're all out of order, 0, 1, 2, 3, 4, 2, 2, 4, 2, whatever. Optimize just means I order them all. So now I have 0s, 1s, 2s, 3s, 4s in order. Note the size doesn't change. That's expected. But now I'm going to go ahead and compress my data. And when I compress data, I'm using traditional compression algorithms. Column Store and Column Store Archive use different algorithms, the proprietary Microsoft algorithms, but there are white papers, they're documented, you can learn a lot about them. And the key to this is going to be aggregating and compressing repeated byte patterns, which means that when we have our optimized data, like this on the right here, it compresses better. I can go ahead and say, instead of storing 0, 0, 0, I could just say store the number 0 3 times. If I have millions of values, if I have a million values in a row group, then it may be like 20,000 or 100,000 values repeated. That compresses down to nothing, right? I don't store it 20,000 times, I store it once. So This mushes down the data and makes it from going giant to small, because now I'm just storing a handful of numbers, and index is saying how many I have. That's run length compression, and it's really effective, and it's used everywhere. Very, very common. So what does this mean for you? There are some important things you can keep note of. First of all, VertiPaq optimization cannot be used everywhere. If you trickle data into a clustered column store that has non-clustered row stores, it won't get VertiPaq optimized. Therefore, you have to rebuild it later, recreate your index, drop the non-clusters. You've got to work around them. If you have memory optimized column store, I'm not really sure why you do, but if you do, it doesn't get optimized. Keep that in mind. It's a rare use case, but just in case. One additional thing to note is that dictionaries are limited to 16 megs. That means that you have to normalize wide columns if your dictionaries overflow. And you can check all the metadata to learn about this. You really can. So there's ways to get around this. And so understanding how data is stored lets you work around it. This is a very, very fast demo. All I'm really doing here is showing you what metadata looks like. And you can then take it from here. I'll send all this out later. Please don't copy. But I can go to views like this and join them against common other views. This is dictionaries, partitions, objects, and so on, to learn about how my data is compressed. How big is it? How many entries? What kind of dictionary is it? I can get information on specific columns. I'm not really going to show that much more here. Like in detail for a certain column, what do I have in there? How is it compressed? A lot more details I didn't present here because we're almost out of time, but a lot more details you can learn about. And for example, you can even see who's been VertiPaq optimized, 1 or 0. And there's reasons, like, hey, there's some zeros. What happened here? I can learn about it and understand better. So I'm going to send all these queries out later. These are examples of my SQL Server provides a lot of transparency into how things are stored. I'm not going to show the rest of this right now. It's meant for a slightly longer presentation. But this is really a nice overview of how column stored data is compressed and stored. And the key to all of this is that you have all these awesome algorithms that give you great compression ratios. It stays compressed in memory, and you can tweak how your data is stored to boost performance. And another beautiful key here you can dig into on your own is those DMVs give you total transparency, which means you can learn as much or as little as you want about how this data is stored. So with that amount of beauty, anybody has any questions? This is a great time to ask. Otherwise, find me later. Feel free to connect and ask questions, talk about what I've said here. I know this is very short. I have longer content on this out there if you're interested in it and want to learn more. I'll take a breath now for the first time in 10 minutes, in case anybody has anything.